Today we're going to be looking at the laws of logarithms again. But this time we're going to use them to do what's called expanding and contracting logarithmic functions, or expressions, I should say. So it's the same thing you were doing yesterday. So here's our laws, the properties of the logarithms. I'll give you a quick example of each one in action here. Okay, so log base 5 of 7x could be written as log base 5 of 7 plus log base 5 of x. So the multiplication here, logarithm of 7 times x becomes log 7 plus log x. Now they're all base 5. You got to keep that base the entire way through. Now if we have a division problem, so log base a half of, well, that'll get confusing there, so let me just make that a nice number 6 of x over 5. That would be the log base 6 of x minus log base 6 of 5. So the division, x over 5, becomes log x minus log 5. Again, all base 6 in this case. And then last example here, log of x to the third power is the same as 3 log x. So the exponent here can be brought out front, and now it is a coefficient of the logarithm. Notice this logarithm doesn't have a base. That means it's a base 10, but again, we just don't show it when it's a 10. That's the common logarithm. So today what you're doing is using these laws to do what we call expanding the logarithmic expression. And it just means to take this logarithm expression, in this case it's a natural log, so that's a log base e. So take this expression and expand it so it's a series of additions and subtractions of some logarithms. So we're just going to apply those laws, and if you notice here, so we've got ourselves a division problem in here. So that right away can be broken up into a subtraction of two logarithms. We have a little multiplication going on here, and then we have an exponent. So let's do them one step at a time. So our first step is to get rid of this division. So we're going to rewrite it as a natural log of 5x to the 7th minus the natural log of y. So that's the law I just used there is log of m over n is log m minus log n. So I did 5x to the 7th over y becomes 5x to the 7th minus the natural log of y. Now we aren't done yet. That was slowly we started to expand it here. See, now we have a multiplication here, and remember multiplications become additions. So now this is natural log of 5 plus natural log of x to the 7th. Then we get that minus natural log of y. And then our last step, natural log of 5 plus an exponent can come out front because that is the power rule of x minus natural log of y. And so that is the expansion of the original logarithmic function. It is now written as a series of additions and subtractions of some logarithms. Okay, so basically you're just applying every single law you can apply to expand it or spread it out as much as possible. This is the opposite when you condense it. I think I called it compressing it earlier, but you're trying now to work it just in reverse. So we're trying to squeeze this all down to a single logarithm. So we're just using the properties working from basically right to left in that as you look at that list. So if you had an addition, you could change that into a single log, that is multiplication. If you have a subtraction, it becomes division. And if you have a coefficient, it can pop inside and become an exponent. So let's just work this in reverse here, so to speak. So right here in my first step, I've got an addition, so I'm going to change that addition to a multiplication. No, I do not want to do that yet. I missed something. Look at this guy sitting out front here, that 3. We don't have a rule on how to add these when we have a 3 out front. So what we're going to do is we're going to tuck that 3 in there first. So that's going to be log base 9 plus log base 2. And see, I'm putting that 3 now inside the logarithm. That's the power property. Minus log of 3. There we go. Now I have a rule about a log plus a log. It says that becomes multiplication, so it's log of 9. Let's see, I guess we'll keep it in blue. 9 times 2 to the third minus the log of the 3. And lastly, we have a subtraction right here. Subtractions are divisions when you compress it all to cubed all over, oops, that's log 3, that, there we go, over 3. So now it's a single logarithm. Now, because we have all known quantities inside the logarithm, we're going to work that out. So that's 9 times 2 cubed is 8 over 3. So that's the log of, you can go with 72 divided by 3. Or I'm going to go 9 divided by 3. That's 3. So it's 3 times 8. So 24. So that's what this big long expression simplifies to, or condenses to. Let's look at a few more of these. Here's 2 expansion ones. So pause and take a look at them. All right, I've got an exponent and I've got multiplication here. Bring that 4 out yet, because that 4 is not on both the 3 and the x. That 4 is only on the x. So I'm going to have to separate the 3 and the x to the 4th, and then I'll be able to use the power rule. So the multiplication becomes addition, and then the exponent gets to come out front, giving us a final answer of log base 6, 3 plus 4 log base 6 x. And we're finished. The one to the right here, let's take a look at him. We got ourselves a subtraction right here, and we have a multiplication. First thing I would do is I'd separate those, get that stuff out of the denominator. So I'm going to have ln of 5 minus ln of 12x. So the division became subtraction. And then this multiplication right here can become an addition problem. But I have to be a little bit careful here because it says subtract ln 12x. Well, when I replace ln 12x, I got to make sure I'm still subtracting what it's equivalent to. So it's subtraction of ln 12 plus ln x. So that still says subtract ln natural log of 12x. This says subtract, and this is what that natural log of 12x is equal to. So now we have to distribute that negative. And that would be our answer. Now, this ultimately should make sense to us because you're dividing by the 12 and the x. That means the 12 is subtracted and that x is subtracted, or their natural logs are subtracted. And that would be the final answer for that problem. All right, let's condense a couple of these. Here's a nice easy one to start with. We just have a single subtraction right here, and subtractions become division. So now it's a single logarithm. In this next example, let's get rid of our coefficient here by making it an exponent. Slide this over so we can see. Go. So we'll go ln of 4 plus ln of 3, and I move the exponent inside. And we've got minus ln of 12. See here, this addition becomes multiplication. So we've got ln of 4 times 3 to the third, then minus the ln of 12. And then our last step, that subtraction becomes multiplication over 12, like that. Now we're going to go ahead, since this is all known quantities, let's work it out. So that's the ln of 4 times 3 cubed is 27 over 12. And then what I would do is go, that's 4 over 12, so that simplifies to a 3. And so I end up with the ln of 27 over 3, which is just the natural log of 9. And I am finished. Okay, that's all there is to today's assignment. You'll be given an original expression, and you have to condense it, or you'll be given an original expression, and you have to expand it. It is on multiple choice today. It's not very many problems. Shouldn't take you too long. So get that done. If you got questions, make sure you